All right, we're on section 6.3. We are looking at our last exponent rule that we're going to talk about this chapter, and that is the power of a power property. So you'll hear exponents commonly called the power of a number. I think I've used that word a few times in these notes. So we're going to talk about what happens if you take a power to the power, or in other words, I have x to the a, where a is my exponent, and then what if I take that whole term and I raise it to another exponent, b? What happens then? Well, all we will do is we will take our variable x and we multiply those two exponents together, okay? So an example, I could take x to the power of 2 and raise all of that to the power of 5. This would equal x to the power of 2 times 5, which would be x to the power of 10. Okay, so we're multiplying these exponents together if we raise a power to a power. Okay, so let's take a look at our first example. Pretty similar to what I just drew. So we have x to the 2, or x to the power of 2, and we're raising all of that to the power of 3. So this would become x to the 2 times 3, or x to the 6th. We're just multiplying them. Okay, let's check this one out. So what happens if I have two variables inside in this term, and I take those to the power of 2? Think of our distribution property. In this case, this power of 2 needs to go to the b term, but it also needs to go to the a term. Because remember, my a technically has an exponent of 1. So what this looks like is I'll have a, and it's technically the power of 1 times 2, and then b to the power of 3 times 2. So this simplifies. I would get a squared b to the 6th. That would be my final answer. The most common mistake I will see is people will get this problem and their final answer will be a times b to the 6th. They'll forget to distribute it to the a because all they see is the b exponent. But that is incorrect. You need to distribute it to both terms, or both variables in the term. Okay, very important. Let's take a look at this example C. Now we have a coefficient. When we're given a coefficient in a problem like this, it is very important to take note on whether or not the coefficient is outside the parentheses or inside the parentheses. Because our exponent that is outside of the parenthesis will only get distributed to the pieces inside the parenthesis. So in this case, my 4 is outside of our parenthesis, so this exponent of 2 is not going to get distributed to the 4, because this 2 is only concerned about what's inside the parenthesis. 4 is not inside. So with that being said, our 4 will just remain a 4. Nothing's going to happen to it. Then I will have k to the power of 3 times 2, m to the power of 2 times 2. And this will simplify to 4, k to the 6th, m to the 4th. Looking at example D now. If I can zoom in. There we go. All right. There are no variables in this, but we do still have an exponent. So all that is inside is a fraction. We can think of this a couple different ways, but I think the easiest way is going to be I have an exponent, and then I have a fraction, so whatever's in my numerator and whatever's in my denominator both need to get raised to this power. So in other words, this becomes 2 to the power of 2 divided by 3 to the power of 2. So I have distributed this exponent to both my numerator and denominator because they're both inside the parenthesis. So if I do this, 2 to the power of 2 is 4. You can use your calculator if you're not sure. And 3 to the power of 2 is just 9, okay? In case you need this little refresher, remember 2 to the power of 2, we're basically just going to multiply 2 times. Same thing, 3 to the power of 2, we're just going to multiply 3 2 times. So what exponents tell us is how many times we're deciding to multiply a certain number times itself. And I realize I just made a mistake. This is supposed to be 3 times 3, right? So if I had 2 to the power of 4, this would be 2 times 2 times 2 times 2, 4 times, okay? So with that being said, let's take a look at example E. All right, we have a number, or like a coefficient number, but then we also have variables. So let's be conscious about this. This 3 exponent needs to go to everything inside of the parenthesis. So I see 4 different things that this 3 has to get distributed to as far as exponents go. Okay, so let's tackle this one at a time. First, we have our coefficient of 2. That is getting raised to the power of 3. Because remember, this 2 is technically just 2 to the 1, but 1 times 3 is just 3. Then we have a to the power of 2 times 3. Then in our denominator, we have b to the power of 3 times 3. And then again, we have c, which would just have an exponent of 1. So this becomes c to the 3rd power, because 1 times 3 is just 3. Some simplifying we can do. I can multiply these exponents together. I can multiply these exponents together. And I can simplify 2 to the 3rd, because like we just talked about over here, that means I'm just going to take 2 and multiply it times itself 3 times. So this would become 2 times 2 times 2. You can use your calculator, but that is just 8. A to the 2 times 3 is a to the 6th. B to the 3 times 3 is b to the 9th. And c is still c to the 3rd. All right. Take a look at example F. I want you to try this one on your own. So remember, you have this exponent of 4 that needs to get distributed to each piece inside of the parenthesis. Okay, so make sure you're distributing it to each of those. Go ahead, try this one out and see if you get the same answer as me. All right, so I ended up getting x to the 12th, y to the 4th, z to the 20th, all divided by 16. Remember, you hopefully got to the place where you had a negative exponent, because originally we had z to the negative 5th, but we have to multiply that exponent by 4. So that becomes z to the negative 20th, but we don't like negative exponents. So that's why I moved it to the numerator, and that changed the exponent to be positive 20. So this is what you should have got for your final answer. All right, we have 3 left. Let's look at problem G. So now we have multiple parts we're going to have to do. First, we have 2 different terms, but each of them have an exponent or an exponent applied outside of the parentheses. So for both of these, we will have to distribute that exponent before we can actually multiply these terms together. Okay? So let's take a look at this. I'm going to start, let's do some color coding here. I'm going to start with this blue piece first. And then after that, we'll take the second one, which I'll make green. Okay, so I have to distribute that power of 2. So I will have 4 to the power of 2. And then I will have x to the power of 2 times 2. And remember, since it's just 4 in here, we can think of it as 4 to the 1. And so 2 times 1 is just 2. So that's why I'm just writing 4 to the power of 2. Okay? And then this will be multiplied by, and now we have to distribute this 2 into all of this here. Okay, so 2 for this exponent here. So this is technically 2 to the 1. So that will turn into 2 to the 2. And then this is technically x with the exponent of 1. So we will write that after multiplying that exponent by 2, it'll just be x to the 2. And then this will become y to the 3 times 2. Okay, now we still need to simplify the terms before we can multiply them together. So, starting with the blue, 4 squared is just 4 times 4, which is 16. X to the 2 times 2 is x to the 4th. So that first term is finally simplified. Now our second term, we have 2 squared, so that will simplify to 4. X squared stays the same, and this becomes y to the 6th. Okay, so now to simplify this, we have to recall back a couple sections ago. How do we multiply variables with exponents? Remember, we add the exponents together for the same variable. So first, we need to take care of those coefficients. So 16 times 4, you can use your calculator. That will end up being 64. And then we're going to have x, and then we have an exponent of 4 and an exponent of 2. We need to add those together. So 4 plus 2 is what I'm doing here, because remember, now we're multiplying. So this is a transition. Up here, it was power to a power, so we multiplied the exponents. But here, it's not a power to a power anymore. We're multiplying the terms, so the exponents get added. Okay, I know it's a lot to remember. Refer back to your notes as much as you need to. So we have x to the 4 plus 2, and then we will have just y to the 6th, because there was no y variable in this term. So the only simplifying we need to do is the x variable. Our final answer will be 64, x to the 6th, y to the 6th. Okay, let's take a look at problem H. Okay, so there are a couple ways you could approach this problem. The easiest way I see to do it is before you mess with this exponent in here, I want to simplify inside of here. So what I mean is I see x's in the numerator and denominator, y's in the numerator and denominator, and z's. I want to simplify all of that, so that way there's less things I need to distribute this to. So let's go ahead and start doing that. So we're still going to have a parenthesis, and that 2 is still going to be on the outside. Now let's work inside. So I see x to the 3rd and x to the 4th. Whichever one of these is bigger, I want to move the other variables to that side, or the other x's. So x to the 4th is bigger than x to the 3rd, so I'm going to move x to the 3rd down there. So when I do that, I'm going to draw my fraction bar. So I will have x to the 4th, and then x to the negative 3. So that's my x's taken care of. Then I have y to the negative 2 and y to the positive 1. Positive 1 is greater, so I'm going to keep the y to the positive 1 in the denominator, and I'm going to move this into the denominator, so this will turn into a positive 2. So then I will have y to the positive 2. And now, take a look here. I have z and z. So both of these are just z to the 1. No matter where I move them, the same thing is going to happen. So let's just move them both up to the numerator, and then we'll kind of see what happens. So I have z to the 1, and then if I move this one up, it'll become z to the negative 1. Okay, so that's all of those taken care of now. So now we just need to start simplifying inside of the parenthesis. So let's start with the numerator first, actually. So if I look at my numerator, I have z power of 1, but I combine the exponent, so I add them together, so it would be 1 plus a negative 1, which is just 1 minus 1. So that's going to be interesting. Then in my denominator, I have x to the 4th, but then I have to subtract the 3 because I'm combining those. And then I have y, and then we're going to have 1 plus 2 because both the 1 and the 2 are positive, so we're adding them. Okay, and remember, this whole thing is still being squared. We will take care of that here in a minute. So now, in my numerator, z to the 1 minus 1 is z to the 0. So recall, that's going to change. We're not going to just leave that as z to the 0. That'll become something else. In my denominator, x to the 4 minus 3 is just x to the 1. And then y to the 1 plus 2 is y to the 3rd. This is all still squared. All right, so z to the power of 0. Do you remember our 0 exponent rule? That just becomes 1, because anything raised to the power of 0 is 1. Okay, so that's the only thing that changed from here to here is I just changed the z to the 0 to 1. Okay, so we did all that work. We finally got all of the stuff inside our parentheses simplified. So now let's take this back up here. I am going to rewrite it. So we have 1 divided by x, y cubed, and all of that is squared. Now I need to finally distribute this exponent to each piece inside the parenthesis. And now this is going to be a whole lot easier because notice I only have to distribute it to 3 things. If I would have done this step first, then I would have had to distribute it to 1, 2, 3, 4, 5, 6 things. And then after that, we still would have had to clean up the inside. So this is definitely a faster method. So as I do this, I have a 1. And so if this becomes 1 squared, we'll see what that does in a minute. Then in my denominator, I get x to the 1 times 2 and y to the 3 times 2. Because remember, this is just x to the 1. All right, so now we just got to simplify this. What's 1 squared? Well, if we think about it, it's just 1 times 1, but that just equals 1. So it's kind of redundant, but our numerator is just 1. Then in our denominator, we get x squared and y to the 6th power. And that is our final answer for problem H. All right, problem I is extremely similar as far as the process you'll do that. So I want you to do this one by yourself. I would highly encourage you to clean all this up first like we did over here. And then after that, I would distribute this 3. So go ahead, pause the video, give this one a shot. Once you're done, unpause and see if you got the right answer. All right, so check your work. My final answer, I got a to the 6th, b to the 24th. I know that's a big exponent, all divided by c to the power of 6.